sorry about that. Anyway, the first quarter now didn't get recorded. Anyway, what we did, we took the formula from the first half and changed it, rewrote it a little bit, did a few manipulations, and as a result, we obtained the following thing: the map D tilde, which is determined by this diagram, is in fact the zeroth Sobolev extension of the adjoint operator of the adjoint operator of D in the naive sense. This adjoint operator is again a differential operator, same as D, of the same order. Are there any questions? Okay. Now,
Сейчас, а что произошло? Я просто пытаюсь понять. Вот, то есть, вот был DM оператор.
Да, значит, DM, значит, он бьет из Соболева в Соболева. Значит, дальше, значит, мы сказали, что давайте возьмем двойственные. Давайте, да, но, значит, двойственный он бьет из двойственного в двойственное. Значит, дальше мы сказали, давайте мы эти вот двойственные отождествим с, значит, соболевским пространством, но противоположных индексов.
И вот D с волной, это значит, который вот между ними.
Да, значит, вот мы, значит, имеем такой оператор D с волной, а что это за оператор? Значит, и путем, значит, несложной манипуляции мы доказали, что это оператор, это, значит, тоже соболевское продолжение, но соболевское продолжение чего? Соболевское продолжение, значит, оператора D со звездой, который есть сопряженный оператор в наивном смысле.
Ага, понятно. Так мы как бы по кругу прошли, и что мы получили в результате
вот,
этого?
значит, ну, значит, мы получили, что, значит, пока мы получили, что, значит, двойственный оператор, если вот так вот отождествить его, значит, source и target, значит, это тоже соболевское предложение чего-то, но, значит, более конкретно сопряженного дифференциального оператора.
Ну, хорошо, это вроде ясно.
Okay. Now, where we? Oh yes, here I forgot to put a zero. Here we take the scalar product not in the sense of Wm, but in the sense of W naught. That's how we define. Because that's how we identify the dual of Wm with W minus m. Значит, то есть в WM у нас есть свое скалярное произведение, которое мы в данном случае не используем. Значит, что мы используем? Мы используем то, что D с волной от X, оно, значит, по определению лежит в W минус m. И поэтому скалярное произведение y на D с волной от x, оно, значит, оно определено. Потому что одно лежит в WM, другое в W минус m. значит, а вот если бы у нас были бы там абы какие элементы, значит, соболевских пространств, то такое искривленное произведение уже бы смысла не имело. Okay, now let's see what else we need. We need actually what we need is is the following thing. We also have the joint operator from W naught of F to W M of E, which is the usual joint operator. Actually, so there are too many different scale products, and this is confusing. So let's try to state a more general version. So suppose we have suppose we have a continuous operator. Then then there is the dual operator. And the joint operator. How are these operators related? Well, let's see. We have the dual operator. This is no, no, sorry. Yeah, this star is supposed to be there. Okay. Okay, I can erase the bars because complex linear maps between the complex between the complex conjugate complex vector spaces are the same as complex linear maps between the same complex vector space. Okay, so I have this this commutative diagram where the identifications are made using the scalar products in V and W.
Oh, A star is linear.
Yes, the map A star is linear, but the map A goes to A star is anti-linear. Well, let's put bars in brackets. The underlying spaces, the underlying real vector spaces and topological vector spaces are the same, and the maps are the same if they commute with one complex structure, they commute with minus the complex structure. So the map is the same. Okay, now well this part is not particularly surprising. Let's see what we get in our case. We have well, we have the now what I want to use is the following thing. I want the kernel of this adjoint operator to be the same as the kernel of I want it to be the same as the kernel of D star. Let's see. The second equality here, the kernel of D star node equals the kernel of D star, is something we proved last week. If I take any subloop extension of an elliptic operator, the kernel is the same. Now the kernel of T star M is the kernel of the adjoint operator in the usual sense. Now let's look at the diagram. The kernel of the adjoint operator is the same as the kernel of the dual operator. Once we identify the vector space, so let me write this down. The kernel of the adjoint operator dn star is the same as the kernel of dn dual if we identify W naught of F dual with W naught F bar using the W naught scalar product. Okay, now but on the other hand, if we identify W naught with W naught dual with W naught using the same scalar product, we see we've just seen that the kernel is that the dual map becomes the dual map becomes T star naught. So my claim is after all these identifications, we get this formula at the bottom of the page. Let's see once again whether or not this makes any sense. Okay, let's maybe draw one more diagram which combines this one with this one. Right, something's not working. Okay, so we're running out of time again. Never mind. Okay, so what do we have? we have okay, maybe let's see if there's okay. I'll try to use a different color. So we have the dual map, and this map can be rewritten as shown here. But we also have the conflict map. Uh, and on the left, the composite of the two arrows is just the identity map. Okay. Now the map D tilde, as we found out, is D upper star node. Okay, now let's look at the bit diagram. My claim is the kernel of the top arrow is the same as the kernel of the bottom arrow. And well, from this diagram, from this diagram, it's this formula is clear. Now, Igor, do you agree? So this identity here follows from follows from the diagram.
Ну, вроде да.
Ну, то есть, вот, значит, обе стрелки присутствуют на диаграмме, и утверждается, что ядра у них одинаковые. Значит, почему одинаковые? Потому что при изоморфизмах, которые слева, они переходят в ядро нашей двоичной стрелки, то есть которые посередине.
Понятно.
Okay. Now the idea is simple. The only thing that's confusing is there are many scalar products and many duals, and it's not always straightforward which one to use. Okay, let's now prove the proposition. So the kernel of DM conjugate, which is the kernel of D, is finite dimensional. This is the fruit of our labor. Okay. Now, what do we do next? Well, the kernel is finite dimensional. From the general theory of Hilbert spaces, we know that the image of Tm is dense in the orthogonal complement of the kernel of Dm. So this follows from well, this is basically true for any continuous operator between Hilbert spaces. Okay, now now my claim is that dm the image of dm is the image of dm is the Sobolev extension of an elliptic operator. So the image of dm has finite finite codimension, and this means that the image of dm is the image of dm is closed. We'll see this in a minute, and using elliptic regularity, which we proved last week, we get the result we're after. Again, I've saved the notes. Let's well, let's